Okay, I promise I will talk about it a little bit on how to find the reflection of a line in a plane. Let's talk about if you have a plane. I essentially want to find the reflected. This is our line L1. If I want to reflect, this is the reflected line L2. Yes? So using the same concept, I will just tell you, do you know the point where the line meets the plane? Can find. Can you find a point A and then reflect A prime, reflected A prime, join the 2 points up, and we're done. Okay? So, next session, we're finding distances. Okay? The last bit of it already. Okay? To sum up, there are 3 methods to finding distances. 3 methods. I won't say which is superior to another. It really depends on the situation. But in general, to find distance, only 3 ways. 1. If you know the coordinates of the endpoints, A and B, I want to find distance A and B. Of course, you've got the coordinates of this, done. Equation done. Sometimes we do not know the endpoints, so we will make use of method 2. Yes, you use the length of projection. Length of projection. Method 3, we use cross product. This is dot product. Length of projection is dot product. I see this is dot product. This is cross product. Now, without any context, I am afraid you may only just listen. You don't know what's going on. But never mind. Even when I tell you this one in this thing, you also don't know. I'm going to jump straight to an example, which will show you exactly 3 different ways to finding the same distance. Using the example, shortest distance from a point to a line. Now, you may have your preferred method, but I need to show all 3 to illustrate the 3 ways of getting distances. Okay, Ken? Let's use example 9. Given that a point A, got this, 3 minus 1, 5. The numbers are exactly the same as example 5, so you may want to refer to example 5 as well. I have a point A, yes, here, and this is a line. Find the distance from A to L. Method 1. If I know, look, shortest distance from a point to a line is effectively the distance from that point to the foot of the perpendicular. I say one more time. To find the shortest distance between A, let's say random, A to the line, I want shortest distance is actually then the distance to the foot of the perpendicular. So we can use example 5, pretend that we have found the foot of the perpendicular, OF is this. Then I just find AF and magnitude of AF. This is actually magnitude of AF. Done. This is method 1. See, I refer you to the notes again. Method 1. Done. Yes? Got 2 endpoints. Find distance. Done. Okay. Back to the same problem. I still want to find shortest distance from A to the line. Shortest distance from A to the line. Method 2. Scalar product. How do I use scalar product? Here. Now look. I can find a point C. Yes? Because this equation of this line, sorry, maybe I write down R here. This is R equals to 8, 0 minus 1 plus T minus 6, 1, 4. So 8, 0 minus 1 lies on this point. This 8, 0 minus 1 clearly lies on the line. Yes, I call this point C. Yes, I call this point C. Now, can I use length of projection if I take CA, I take CA here, dot this direction vector, which is minus 614. Why do I know it's minus 614? This is the direction vector of the line here. Yes, minus 614. So if I take CA dot the unit vector of minus 614 and I mod it, I will actually get what? I'll get CF here. CF. So let's do the numbers. I'll get CA is minus 5. Okay, wait. Before that, no. Let us work out what is CF. Okay, I think there's one step missing. CF or CA, I beg your pardon. Wait, where's my CA equals to OA minus OC. OA is 3 minus 1, 5. OC is 8, 0 minus 1. So this eventually is minus 5 minus 1, 6. So minus 5 minus 1, 6. Dot unit vector 1 over root 53 minus 614, like that. All good? Yes? So by taking projection of CA dot product CA dot unit vector of minus 614, I will actually get CF. I calculate it out. You realize that it is 53 over root 53 is actually root 53. Now what you have found so far is only CF. You use dot product, you use CF. But what do we want? We don't want CF. We want here. We want this one. We want this distance. This is the shortest distance. I want AF. By Pythagoras theorem, I can find AF is actually square root CA square minus CF square. Then we find AF blah blah blah. I get 3. I let you decide which one is better. You look through all the 3 methods first, and then you decide for this purpose of finding shortest distance from a point to a line. I let you decide which one is better. Method 3. This is what I call cross product. Look at this diagram again. You must know your cross product dot product very well. That diagram, remember? The formula here. You find this formula? If I find CA and I know this vector is minus 601 and I want to find AF directly, distance only, distance only AF, I think it's quite obvious we can immediately use this formula. CA cross unit vector of U. Of course, we take the magnitude. If you are not sure, go back and revise on your projection on this diagram where you last seen this formula. Okay, alright. So let's do the math. Let's do the simple thing of finding CA, which is CA we found earlier, minus 5 minus 1, 6 cross 1 over root 53 minus 6, 1, 4. 1 over root 53. I take cross product. I'll get a minus 10, minus 16, and minus 11. I get square root 477 over square root 53. Oh, sorry. This one already have. Sorry. Then from here. Then you get root 3. Done. Root 9, sorry. Done. Can I leave all of us with this question? Why don't you take the next 1 minute to look through the 3 methods and answer to yourself. Do you understand all 3? Important. Don't just because you favor one, then you think, oh, the other's not important, because it really helps you revise on the concepts. But after that, you think to yourself, which one seems the fastest and most direct? Yes? Can? I don't want to give you answer. I will tell my tutorial classes, but I don't want to influence you. Can?